on a spring oscillating with a period of 0.80 seconds, amplitude 10 centimeters. At t equals 0, so this is the initial time, the initial position is 5 centimeters to the left of the equilibrium, so right here, and it's moving to the right. So let's say that this is our equilibrium. That means x is equal to 0. And here's where our oscillator is at t equals 0. So this is t equals 0, x of 0 equals 5 centimeters left of equilibrium, so it's minus 5 centimeters. It is moving to the right, so the direction of motion is this way. So our oscillation is about the equilibrium back and forth this way. The amplitude, we don't know what it is, but it has to be bigger than 5 centimeters because right here it's moving forward after it reaches the amplitude and turns around. So there's some stuff that we know. The amplitude is given at 10 centimeters, so we do know the amplitude. So right here it's halfway between the amplitude and the equilibrium. So part A says write the equation of motion. So equation of motion means we're writing the equation x as a function of t. Equation of motion could also be called the equation for position. So x of t we know is the amplitude times cosine of omega t plus phi naught. So now what we have to do is figure out what are we going to put in for a, what's omega, and what's phi naught. A is really easy. A is 10 centimeters. Okay. Omega is pretty easy. Omega, we remember, is the angular frequency. It's 2 pi divided by the period. The period was given, it's 0.8 seconds. So our angular frequency, omega, is 7.85 radians per second, or just seconds to the minus 1. Either way is okay. So now the last part is phi naught. What is our phase constant? We've got to figure that part out, then we'll put that number in, and then we'll be done with our equation of motion. So we have to ask, what do we know that we can plug in? What equation can we use, and how are we going to use that to get our phi naught? Well, what we know is that if t equals 0, x is equal to minus 5 centimeters. Let's put that in this equation and solve for phi naught. So minus 5 centimeters equals our amplitude, 10 centimeters, times cosine of omega, 7.85 radians per second, times our time, which is 0 seconds because this is at t equals 0, plus phi naught. So minus 5 centimeters equals 10 centimeters times the cosine, 0 times 7.85 is 0, of phi naught. Divide both sides by 10, we get that cosine of phi naught is minus 5 centimeters divided by 10 centimeters equals minus 0.50, okay? And our centimeters cancel, so we don't have any units there. So now what we have to do is to get rid of the cosine, we take the inverse cosine of both sides. So the inverse cosine of minus 0.50 equals phi naught, and we're trying to find our phi naught. So what this means is what angle, when we do the cosine of it, gives us minus 0.5 for our value. So we take our calculator, we make sure it's in radians mode. Okay, my calculator is in radians mode. And then I do inverse cosine of negative 0.5. And what my calculator tells me is 2.09. So my calculator says 2.09 radians. Now we have to ask, is that the only answer? Is 2.09 the only angle? I can do cosine 2.09 and get minus 0.5 for the answer. So if I do cosine 2.09, I get minus 0.5 with a little bit of rounding. But is there any other angle we can use? Well, we know that cosine of theta and cosine negative theta are exactly the same. And we can think about that if we look at the unit circle. So 2.09 radians is somewhere over here on our unit circle. Okay, and our cosine part is the part that's along the x-axis. So this one has a cosine of negative 0.5. But you know what? So does this one, negative 2.09. So we have to think, because our calculator doesn't always tell us the whole story, our phi naught could also be minus 2.09. We have two choices. Okay, now if we want to think about it, we really have an infinite number of choices, but for right now we'll stick with two. Let's just test that if we wish. Cosine of minus 2.09 gives us minus 0.5. Okay, so we're confident that those are our two choices. So now we have to ask, how do we sort out which one is the correct one? Well, we know that at t equals 0, the oscillator is moving to the right. So what does that mean? It means that the velocity is positive. So at t equals 0, the velocity is greater than 0. So now our velocity equation, v of 0 is equal to minus a times omega times sine of omega t plus phi naught. Okay, and omega t is just going to be omega times 0. It's going to be 0. So let's test our two answers. If phi naught equals plus 2.09, then sine of 2.09 is a positive value. This is positive, so our initial velocity is negative. If phi naught equals negative 2.09 radians, then our initial velocity, so let's do sine of minus 2.09. So then our velocity, this term is negative times this negative, is positive. We know that our initial velocity is positive because it says it's moving to the right. Therefore, this one is wrong and this one is correct. So now this has to be our correct phi naught, and our equation of motion then is x of t equals our amplitude, 10 centimeters, times cosine of omega, 7.85 radians per second, times t, and we put in our phase constant, 2.09 radians. There's our equation of motion. And in the next part, we'll find the position and direction at t equals 2 seconds.